Hello, everyone. Today's lesson is decimals. The word decimal comes from the Latin decim, meaning 10. For example, 23.5, the dot in 23.5 is the decimal point. Decimal places. So here is a decimal places. Let's say we have 12.618. What does this mean? All right. So we have make a table like this. All right. So decimal point right here. Ones, tens, and tenth, hundreds, thousands. All right. So therefore, we put on place decimal places. Put one there. Put down two there. Decimal point. 6/10, 1/100th, and 8,000th. So this decimal point. Okay. Next, decimal fraction meaning expanded notation and common fraction notation. Okay. So here, let's say, can we create a table like this? All right. So decimal. All right. Fractional meaning. And then common fraction notation. So therefore, we will have a decimal, which is 5.3. Now, what's the meaning for this? That means we have a 5 plus 3, 10. And then what's the common fraction? Notation, which is 5 and 3, 10. Okay, this is called common fraction notation. Okay. Convert each of the following to decimal. Convert this to decimal. So 56 over 100, right? 56 over 100, right? So therefore, we can find it now, convert this. Actually, we can put on the 56 there first, right? Now decimal, 56 decimal is right here, right? Divided by 100, so that would be divided by 10 right here. Divided by 100 there. So actually the answer 10.56. 10.56. That's one way we can do, right? Do we have another way we can do this? Yes, we can do by dividing, long division. The long division always work. 56 divided by 100, right? So therefore, we put on the 0 there. And we have, because the 100, we want to next place value. Put on the 5 there, 500, minus 560 minus 500, 60. and then moving on, next place value 0, 600, 6 times 100, 600. So therefore we got a 0.56. That's another way we can do, okay? So either you want to count, because this, you can count the decimal point, or you can do the long division, okay? Now what about this one? 205, right? Now 205 divided by 10,000, 10,000 divided by 10,000. So therefore, what we can do is counting out the decimal point, 10,000, right? Divided by 10, right here, 100,000, 10,000, because 1, 2, 3, 4. We have 4 0 there. So 1, 2, 3, 4. Oh, moving decimal point. To the left or to the right? To the right, to the left. So the answer is 0.0205. Okay. Now what about this problem? We have a 3.85, right? Now we divide it by 1,000, so we can count the decimal point. Divided by 10 is right there. Divided by 100 is right there. Divided by 1,000 is right there, right? So that's why we put on the decimal point, 0, 0, right? So the final answer is equal 0.00385, 385, okay? So this is converting decimal points. Next, terminating decimal. Terminating decimal that can be written with only finite number of places to the right of the decimal point. Okay. So terminating decimal. 1/2. Terminating decimal, yes or no? Which is 0.5, right? Yes. 1/3. Terminating decimal, yes or no? 0.333. Never end. It's a 333, right? No. So this one is not terminating decimal. No. Okay. Yes. How about 1/4? 1/4. You take a 1/4, which is 0.25. Terminating decimal, yes, we're terminating, yes, which is 5. 1/5. Terminating decimal, yes or no? Yes, we terminating, yes. 1/6, which is equal 0.666. 166, and so on, right? Terminating decimal, no, because never end. 17.142857, 142857, and so on. Yes or no? Terminating? No, this is not. No. How about 1/8, which is 0.125? Yes. All right. What about 1/9? Terminating decimal, yes or no? 1. No, this is a no. 1/10, decimal, terminating decimal, 0.1. Yes, this is yes. All right, so now we have so many example, show terminating and not terminating, okay? Now what about, we have a theorem for this. A rational number A over B in simplest form can be written as terminating decimal if and only if the prime factorization of denominator contain no primes other than 2L5. Then that will be terminating decimal, okay? So let's take a look at the example for this. Which of the following fraction can be written terminating decimal? 7, 8, yes or no? 7, 8, yes or no? Now 7, 8, actually, 8. All right, according to the, first of all, we have the exam. 7, 8 is can we simplify, yes or no? No, we cannot simplify. So that would be 7, 8, right? Now 7, 8, terminating decimal, yes or no? And actually we have 8, right? 8 actually is what? The factor is a 2, right? So yes, so therefore is yes. So if you calculate this, 7 divided by 8, which is equal 0.875, right? Now what about 11 over 250, terminating decimal, yes or no? All right, yes. If you examine this, 0, we have 0 there. So therefore, yes, we have a 0.44, terminating decimal, yes. Now what about 21 over 28? Now 21 over 28, actually this is a 4 times 7, right? But don't worry, we have to reduce. Can we reduce 21 and 21 over 28? Yes, we reduce. 21 actually is 3 times 7. 24 is 4 times 7. So we reduce, make it as 3 over 4. Oh, 3/4. 3/4 actually is 0.75. Terminating decimal, yes or no? Yes, because with 4 is divisible by 2, right? All right, terminating decimal. Next, rounding decimals. Rounding decimals. So here we're gonna discuss computation with a decimal, rounding decimals, adding and subtracting decimal, multiplying decimal, dividing decimal, okay? So rounding decimal, what's the first problem? Rounding 3.6147 to the nearest tenth. All right, so nearest tenth. So we have to go down next place value. Nearest tenth. We'll take this one exam. Oh, since this is 1, so therefore the answer will be what? 3.6, right? Next, round 0.015 to the nearest hundreds. Nearest hundreds, so that'll be tens, hundreds, and thousand. So we have to go down next place value to exam. Since this is a 5, right? So we have to round it up, and the answer will be 0.02, right? Next problem, round 7.456 to the nearest hundreds. All right, so nearest hundreds, so the nearest 100, so we have to go down next place value, to thousands to exam. Now 6 is more than 5 or less than 5? It's more than 5, which is, so do we now more than 5? So we have to round it up, and this one make it as how many? We have to make it this is a 6. So the answer is 7.46. Okay. Nearest tens. So we have to go take this number to exam. Now this number to exam, this is more than 5, right? More than 5, so therefore the answer is 7.5. And we round it up, okay? Round 7.456 to nearest units right here. So we need to take this number 4. right? To exam. So this is 4 is greater than or less than 5. It is less than. So the answer would be 7, okay? Next, 18 and subtracting decimals. 18 and subtracting decimals. $23.47 plus 7.81, all right? So we can do two methods. Method 1, all right? So we can do the column, tens, one column, ones, and decimal point, 110, tens, hundreds, all right? So now we're gonna fill in a number, right? 23, when lining out the decimal point, lining out the decimal point like this, okay? So that'd be 23, decimal point there, 4, 7, okay? Plus 7.81, 7.81. So add the total, add out the total, we got 8 for this, and we got the 2 for this, 12, 12, carry on 1, 7 plus 3 plus 1, which is 11, along 1 there, carry on there, so 2 plus 1 is equals 3. Don't forget the decimal point, so the answer will be 31.28, okay? This is a standard, algorithm, standard, algorithm, and it's for everybody, okay? Now what about, do we have another way we can do? Yes, we can do another way for quick learner, okay? Now quick learner, what we can do is called compose, decompose, this is called compose and decompose method. Now compose and decompose method, basically we can decompose, this is 23 and 0.47. We can decompose it as 7 and 8100, right? And then, again, this method is good for quicker learner, like a mental computation. So 23 plus 7 whole number plus whole number, decimal plus decimal, which is 30 plus 1.28, and add together is 31.28. Okay, this is good for quick learner for mental computation. Okay. All right. So now, what about subtraction? Now subtraction, again, we can use the standard algorithm. All right. Can use the standard algorithm like this. All right. Ones, 1/10s, hundreds. All right. So 2.35 and decimal point where? Where's the decimal point? Point right here. So 2.35 like this. I want to subtract what? 1.3, 1.3 right there. All right, lining up. So 5 minus 0, 5, 3 minus 3, 0, 2 minus 1, 1. So 1.05, right? 1.05. So that's the standard algorithm, right? Now, can we do another way for quicker learner with a compose and decompose? Yes, we can do this for compose and decompose. So here we have a 2 and 0.35. Here is a 1 and 0.3, right? Now subtract. That would be 1. Subtract. That will be 0.5. So final answer will be 1.05. Okay, we still get the same answer like a standard algorithm, right? Okay, that's the adding and subtracting decimal. Now, what about multiplying decimal? Okay. 1.2 times 1.3. 1.2 times 1.3. I think many students, they would do the problem like this. They take a 3 times 2, got a 6. Take a 3 times 1, got a 3. 1 times 2, got 2. 1 times 1, got a 1. Right? And then final answer, oh, lining out the decimal point. What's wrong here? They basically just simply wrong. This is a misconception. This is basically, misconception. So we don't lining out the decimal point here. We don't do this for multiplying decimal, okay? So this is a misconception. This is totally wrong, okay? Now, what is the correct way to do? The standard algorithm is like this, all right? Then you, first of all, you have to ignore the decimal point. Ignore the decimal point, all right? So therefore, we take a 3 times 2, got 6, 3 times 1 is 3, 1 times 2, got 2, 1 times 1 is this, all right? And then add it up total, 156, all right? See, then next we count the decimal point, that 1 and 2. So decimal point, right? We have to count 2. That'll be 1 and 2. All right? We count the down decimal point, 1 and 2, right? So therefore, the answer is 1.56, right? 1.56. Now the question is, why do we move that decimal point? Have you ever thought about this question? Why do we move that decimal point? Let me answer you why, okay? One point before students learn decimal, do they already learn fraction? Yes, they have math. I think their previous knowledge is a fraction, right? So can we say 1.2 is 1 and 2/10? Make sense to you? Yes. Times 1.3 is 1 and 3/10. Make sense to you? Yes. So therefore, we change into improper fraction. That'll be 12 over 10 times 13 over 10. Is that right? Okay. So therefore, 12 times 13 and over 10 times 10. So therefore, we got 156 over 100, right? So 156 divided by 100, which is 1.56, all right? Which is 1.56, right? So now, if you look this 156, if we divide it by 10, is right there. Decimal point right there. Divided by 100, oh, the decimal point is right there, right? Now, in answer the question why we have to move the decimal point for this. All right. We say ignore the decimal point. That means here we times 10. Here we times 10. So that's why we take a 12 times 13, right? And then 3 times 1 is equal 3 times 2. 3 times 2 is equal 6. And then here 3 is 2 and 1, 156, right? Ignore the decimal point. Then next, we move the decimal point, to the left. For how many? For 2, all right? Because we count 1 and 2. What does this mean? Because you 10 times 10, you times 10, another 10, which is equal 100, right? Right? So that's why we say ignore the decimal point. Make it as a 12 times 13, right? So now we have to divide it by back. So you can see divided by 10 there, divided by 100 there. So that's why, we divided by 100. So that's why we move our decimal point right here, right? So that's the reason why we back to, the fraction, and to explain this, okay? All right, then next problem, 12 times a 0.11. So here, I can do both methods, okay? 12 times 0.11, all right? Again, the traditional algorithm is ignore the decimal point. Yes, so 1 times 2. 1 times 2 is 2, 1 times 1 there, 1 times 2 is 2 there, 1 times 1 there, right? You completely ignore the decimal point. All right, now we have to, because there's how many there? 1 and 2, right? So therefore, we have to move the decimal point back. 1 and 2 divided by 10 divided by 100, so therefore is 1.32, okay? Now what about fraction? If we do fraction, you can compare 12 times 0.11, which is equal 12 times 11 over 100, is that right? Which is equal 12 over 1 times 11 over 100, which is equal 132 divided by 100. Now, when we say we ignore the decimal point, which is we just take take a 12 times 11, right? Then we have to divide it by 100 back. So that's why we got a 1.32, right? Okay, multiplying decimal. And next, dividing decimal. 25.5 divided by 5. So 25.5 divided by 5. Okay. So now we put on 5 there, right? Got a 25, right? And then decimal point right there. What about 5? Moving down 5 there. Moving down 5 there. Okay. It's better to use the arrow sign to, lining up. Okay, that's the place value. So 5, so put on the 1 times 5 is equal 5. So the answer would be 5.1, okay, or 5.1. Now, next problem. 25.5 divided by 0.5. All right. So in this problem, we have to move the decimal point right here. And we have to move the decimal point right there, right? So any of the decimal point here, we have here is a 5, which is 25. The traditional way is like this, and then moving on 5 there, all right? And then 5 there, 1 times 5, which is equal 0. Now, the traditional way of doing this, sometimes, student will forget about where's the decimal point? Where's the decimal point? Now, actually, decimal point, we already moved right there. So the answer would be 51, right? But many students, they just lining up this, which is got wrong, right? No, I think so we have moved the decimal point and also put on right here, right? So this is the traditional way, sometimes is more confusing of this. Do we have better way to do this? Yes, we have better way of doing this. Let me show you. We have a better way of doing this problem, okay? When we say we move the decimal point, like this, that means what? That means we make it with times 10, right? Then you got a times 10 for this. Times 10, make it as of 5, right? Now times 10 for this, make it as 255. I would suggest, we will start a new one like this. And in this way, we don't make a mistake, all right? So now we times 10, make it 5. Times 10, make it as 255. So therefore, we take a 5 times 5, 25, and moving down 5, and 1. Oh, so the answer would be 51. All right, 51. Now, how about if I have a problem like this? 25.5 divided by 0.05. Again, 25.5 divided by 0.05, right? Now we're gonna move here, 1, 2. That means what? We times how many? We times 100, right? Times 100, that's why we have a 5, right? Then how about here? We got times 100 there as well. Make it equivalent. So we have a 2550, right? So we move the decimal point like this. So therefore, we have a 5 there, 25. Moving down 5, got a 1, which is equal 5. And we got a 0. So the answer this time would be 510. 510, okay? All right, thanks for watching and hope you enjoy this video. And then if you have any questions, please send me an email. I will answer you. Thanks. Have a great day. Bye-bye.